Making Harrison mill drawbars, part 2, that's the final part. Original, new. Now the next job is welding, but I want to check that it fits in the mill first before we do something that can't be reversed. Just putting a couple of threads into the back of that adapter, I just want to measure how much travel there would be to knit that up. I can't see your side, but I think it reads about 17 mil, something like that. This is the setup for welding. Now I've put it on my welding positioner. This is an old conveyor belt motor that I got for maybe £10 from the Auto Jumble. I bought this chuck separately for £10. It was in a very scruffy state. I mounted this onto this. This part here is the earthing side of the circuit. So there's a copper plate just there. I thought about making something with big brushes, but I couldn't find the right brushes at a sensible price. So I went for this kind of homemade setup. Now, I don't need it for this job, but actually there's a gas passage through here. So if we were welding something and we needed gas to come out through the centre of the chuck, then there's a connection underneath. Oh, it's there, look. Put the argon feed on there, and then it'll blow argon from behind. So there was quite a bit of work involved in that. Now this thing, typically you need to warm the work first and then start it spinning. So I've got a foot pedal for that, excuse me. 1 foot pedal. And I've set up this trigger switch on my torch. Now normally I would use the TIG foot pedal, but I can't use 2 foot pedals at once. The one for this rotator is just an on-off pedal. So if I press it, now this is going to spin far too fast, but I've been running it for a while just to warm it up a bit because it is pretty cold in here. So if that was the right speed, I'd be warming it up and then I'd have a go, start to weld. You see the big block here, I'll need this to support. I'll start with this one, this weld here. So I'm going to slow this right down now to a crawl. This is more like the speed that I need. Now that's probably running that motor at 5 Hertz, and this is where you need a really good inverter, an industrial grade inverter to run at 5 Hertz or even less actually. Now ideally I would have a larger reduction on this gearbox, but I just don't have it, so this is what we're working with. And before anybody really stresses out about this overheating the motor, well, number one, you can see maybe a couple of minutes would be the longest it would run. And number two, it's protected by the inverter anyway. So I've put the motor parameters, this is only 60 watts, plus the current, which is 0.42 amps maximum, into the inverter. So, you know, worst case, the inverter will error and just stop the motor. Now, taking all those factors into account, it's quite a neat little setup. The issue is not this, the issue is my ability to weld nicely. I've ground the electrode to a very sharp point. And in this first weld here, I'm not going to use filler wire, I'm just hoping to blend one metal to the other. Now the thing with TIG is, if that's not sufficient, you can go back over it. It's a clean weld. Now I'll do this first one, show you, but for the others I'm going to do off camera. So, purge, eyes down, start to heat. For this weld I used filler wire. It's ER80SD2 or A31 if you prefer. Now I encountered a couple of problems. The first was that the rotator was turning too slowly, but more importantly it was turning the wrong way. You probably shouted at the set, didn't you? The set, the phone, the tablet, the whatever, it's turning the wrong way. So it didn't really matter here because I wasn't using wire, but here it was obvious. Now it's given this a little bit of a fillet here. I'll just have to machine this back a bit to clean it up, but I think that'll be okay. When I make the next one, I think I need to cut a lot more of this out because there's no room to fill there. It's all going to end up as a fillet. Lessons learnt. And I need to come up with a steady rig because this is now like, I don't know, another 250 in the air. Something for my arm. The trusty bucket should do, I think. Yeah, we'll try at that. Well, for me, that's not too bad. But any lapse in concentration, forget it. That's finished now, apart from the two flats on here, which will be 3/4, 19mm. Now you can see there's a bit of undercutting, such as here. Now I could, if I wanted to, just create a relief there and machine that out so it just looks pretty, because there's enough plane here at 3/4 as the end support, which is what it is, like an end bush in the spindle, but I don't need to do it. It's possible that the later ones that I make will be better than this, better to look at, functionally just the same though. I'll put the vertical head on to mill the two flats on the drawbar. It's quite handy having this wooden cradle, but the whole thing together is over 35 kilos, so multiply 2.2 if you want pounds. So it's quite heavy to lift for me. I might make a crane one day. Cutting the two flats on here, 19mm, 3.18mm cut, cutting in by 16. Using a collet block here, square, machinist jack at each end, just checking that my bar is actually parallel with the bed, which it is. So the plan is, when I come to cut the other side, just unscrew, turn that 180, put it down, check it, go again. The nut on the collet block rests up against the end of this jaw, so that gives me a registration in the x-axis. So when I flip it, I'll get it back in exactly the same place, x, y's. Well, it's finished and the 3/4 spanner fits just fine, and it does measure 19.05mm, which is 3/4. Well, that's the first drawbar finished. I mean, would I say it was a prototype? I don't know. I would have preferred not to have this undercutting on the weld here, but it's perfectly functional. I've even put UNC on the end. UNC, there we are. UNC. I didn't dress this weld up, couldn't see any point. Now I'm working in batches, doing all the cutting, doing all the turning, doing all the welding, doing all the milling for all of the drawbars. That's 1, 2, 3, 4. Well, I've been having a great time just batch producing parts for these 4 other drawbars. Now I'm just parting off the last one of these tops for these vertical drawbars, like this one, which I can't leave there obviously. So this is, I think, my 5th one of these, so in all probability there won't be a jam, because the others didn't jam. You just hope, don't you? This is one of the best things I ever bought. This blade that fits in the, what do you call it? Multi-index. I forgot, multi-tool, I forgot the name of it for a second. Multi-fix. We're turning at 120 RPM. I think we could probably turn it up a little bit now. (140 RPM). Are you still there? And it should just part clean off, and this part should stay on this reamer. Being careful not to get the reamer sticking in too far. Am I getting a bit casual about this? Maybe, actually. We'll see. Oh, it's parted. There we go. I need to put these tops onto the bars. Now there's not much of a press fit, and I'm just thinking, rather than getting the press set up, I wonder if I can do it this way. This one might be a bit tighter. Oh, that's fine. Good. Some improvements the second time around. These are all a proper press fit. 12mm, half, and then this is the second horizontal drawbar, and this will be half width. And I've done various chamfers here and there, which should improve the welding a little bit. And this time around, I'm going to weld all of these. I'm going to put the flats on, and then I'm going to thread them, because last time I had a lot of difficulty holding the bar whilst I was threading. It was just spinning in the vise, but with the flats on, that won't happen. So a much deeper chamfer in the end, and a small chamfer here. It just should help with the welding a bit. And the same with this. Good chamfer on the end, bit of a chamfer there where my thumb is, another one on the inside of this washer, and this will just be like we did the other. We'll just melt these two together here. But there is a small chamfer actually. They are all welded. But I have to say, I'm a bit disappointed, because I thought I could do better than this. You know, having a second go at it. The tops are fine. That'll be good when I just machine off the end there. That'll all clean up nicely. But there's too much undercutting. Still, that one's not too bad. This one's undercut quite badly. So you guys can tell me what I'm doing wrong, but I'm not happy with that really. I thought I would have improved a bit more with the practice. Well, they're all machined and cleaned up. Some of them don't look too bad, but you can see there's still undercutting into this bar, which I'm not happy about. Quite bad there, look. This one really isn't any better than the other one, the so-called prototype. But still, they're fully functional. I'm just disappointed with my welding. The new drawbars have quite a bit bigger head-on than the original. If I put the original there upside down, you can see the difference. And these new ones sit right across the top, full width of the spindle. and this one didn't. And there's quite a big chamfer as well in the top of this spindle. So I think these will be better. So the old and the new, excuse me, this is handheld. I think that's better. Well, I've finally got the hang of this setup. This vise has been spot on for this. It holds the block perfectly squarely, there's no slip, there's no taper on this flat, and also the handle repair has been really good, and this handle now feels very assured. Just 0.5 millimetre. But these chippings are very hot, even with the coolant. Keeps stinging my hands. Well, I'm cutting the first pass on the thread, 1/2 UNC on one of the vertical bars, and the one I've got in my hand is going to be 1/2 inch Whitworth. Now I've been quite careful to get the UNC ones done first and then move on to Whitworth, otherwise my horizontal bars would end up as 2 1/2 inch UNC and then I'd be screaming. So first pass is with the die open, and we've got the advantage now of being able to clamp the flats, because it's really tough cutting this and it spins so easily in these jaws. So I'll come back when I've done, because you've seen this before basically, haven't you? This is a good setup to get the die started straight. Tailstock, chuck in, front of the chuck against the back of the die stock against the saddle here. Simply pull it down manually, and at the same time just tighten the tailstock, which you can't do without getting across you, but you get the idea. Now why I didn't think of this in the first place, I don't know, but now I've seen it, it's kind of obvious really. So once I'm started a bit, I'll take this out and put it in the vise. So this is the first of the two in 1/2 Whitworth, and I can already tell that this die is sharper than the 1/2 UNC die. This is only first cut, so the die's opened. Now, when I cut the 1/2 UNC, I tried to make it a good, nice thread in the one adapter, and then I found that it wouldn't screw into the second adapter. So there's an issue of tolerance somewhere to deal with. I may have to go back and recut a bit off that 1/2 UNC if I want to use that second adapter. You know, life would be a lot easier if you knew how to do everything before you started. It'd save you a lot of time. These jaws, these external jaws, grip this better than the internal jaws that I've got, and the internal jaws need sorting out because they're bell mouth, but that'll be another story for another day. Finished at last. UNC short, Whitworth short, UNC long, Whitworth long. 12 millimeter thread not cut yet, because I'm going to wait till I've got a split die before I cut that thread. And there's the old 12 millimeter. So this thread's quite worn at the end here. It's all right, but this is a better head, the new head, than this one. This is narrower, and it's got quite chewed with the spanner. So I think it's worth having a new one. Now with this one, UNC long, that's definitely a 1/2 UNC thread, but it's too tight. Now I've got UNC adapters that will screw onto this new drawbar, no problem. And actually this screw will screw into this, but I can't get a tap through this. And it's so hard, I'll end up snapping the tap off. It won't cut this, it's too hard. So I don't know what I'm going to do about that yet. I mean, I've got this one which is almost identical to this one. So I don't know. Well, how do I feel about those? Well, they're going to be extremely useful. It's been more work than it should have been. I think I've made, well, I missed 1 or 2 tricks, to be honest. I could have machined these short bars out of solid quite easily. Machining down from 25mm stock to 16 wouldn't have been very difficult to do. But for the long ones, maybe fabricating was quite a good way to do it. One thing I have learnt is if you buy cheap letter punches, it's not great if they're softer than the material you're trying to punch. So I've got some bad punching and flat letter punches if anybody wants them. Thanks for watching.